Welcome to Mixed Reality Simulations for Space Habitats, a NASA collaboration between Virginia Tech School of Architecture and Design Interior Design Program and the Space Habitat team at NASA in Houston. The purpose of this project is to look at the design of space habitats from the context of interior design. So looking at issues of privacy, acoustics, ergonomics, and other issues that impact the health, safety, and welfare of the astronauts while in the habitats. The context is that according to the world scientists who gave a second warning to humanity in 2017, humans and nature are on a collision course. And so many forward-thinking organizations and people are looking at ways to be able to have human beings live elsewhere outside of planet Earth. Just looking at some of the things that the world scientists' warning to humanity included, it was everything from the depletion of fresh water and forests to the increased carbon dioxide emissions and climate change temperatures. So if we look at someone like Elon Musk, who founded SpaceX, one of his primary motivators was that in order for the human species to survive, there needs to be a second place for people to live, not all be on one planet. This is a more inspirational message that he has shared about the excitement of going to outer space, which of course I think many people are fascinated by. So while some of the designs have been aspirational, we are making a lot of progress in this area. And space is something that people have been fascinated with for many years. So if we could look back as far as 2001: A Space Odyssey, this was one interpretation of what that environment might look like. Of course, The Martian had a more high-tech version of this environment, which you're seeing here. This was kind of the main control room, and you see there are lots of windows and views out and big spacious interiors, which in fact there are more limits than this currently on the design of these spaces. Here's another view, and you see them all gathered around a computer screen, and you can see some of the canvas bags for storage in the background, which is what NASA currently uses, and we'll see that in some of the student solutions. So the timeline for this project, we began in the fall of 2018, and this is a two-part class for a senior level undergraduate thesis. So in the fall, there is a 3-credit-hour research course followed by a 6-credit-hour design in the spring semester. So in 2018, we started on the project. In early 2019, we visited Houston and did a tour of the NASA facilities at the Johnson Space Center. And then we also did a one-day charrette with the Gensler Transportation Group, representing Dallas and Houston, both those offices, in the Houston office. Then in the spring of 2019, we had our first round of solutions, which we are now in the 4th round of those, completing this semester. So when the students were at NASA, we actually got to see 2 full-size mock-ups of the International Space Station. Here, circled in red, you see the Space Habitats team. The other 4 individuals are the students who worked on this, and then of course you see them posing with an astronaut. To the side, you see what looks like a swimming pool, and that is where one of the International Space Station mock-ups is actually submerged in a pool to replicate the gravity conditions that someone might experience on the moon. Here is one of the full-scale mock-ups of a space habitat, and it shows you several things that the students had to take into account. One is the importance of establishing up and down, because in space that is not something that you automatically recognize. The other is the necessity of having 3 escape hatches. And then you also see these racks that have laptops and various things affixed to the racks to keep them from floating in space. The other thing that you will notice, like here is the starboard hatch, and there is an exercise bar in front of that. The need to have spaces that could be used for more than one purpose is really important in this environment because of its many size limitations. So here you see a close-up of one of those racks. You can see a combination of light fixtures, computers, and other things, and all of this is to keep things from floating around. So here you will also see another view of one of the other hatches, and here is the port hatch. So that gives you a sense of the limitations inside one of these space habitats. The size is limited by what can actually fit in a rocket and be sent into space. It is also limited by something called payload, which is the weight of all the materials, because most of what goes into one of these rockets is actually fuel in order to send whatever the weight is out of Earth's gravity and into space. So there are size limitations and weight limitations. The students got to see a real rocket that had gone into space and all the component parts. And here you see, just as a scale reference, the size of the students compared to the size of one of these rockets. Again, most of which is used for fuel. Here is an overview of the submerged version of the International Space Station in a big swimming pool to kind of create the similar gravity conditions to the International Space Station. You will see there is a lot of diving equipment, and there are these metal bars that are used to hoist things into the water. When they put an astronaut into this submerged condition, it actually requires several divers to make sure that the cables don't get tangled and that the astronaut is safe. And here is some additional equipment. You can see that they're getting ready. Here we have the astronaut actually in the process of being suited up for being put into this submerged International Space Station. The spacesuit itself is really heavy, so it takes several people to help the astronaut get the suit on. And then once it's on, they are hoisted up. You can see the top part of the suit on the hitched to that bar in the background, and that's what will actually be used to lift the astronaut and to submerge him into the pool. And here he is, almost ready to go. You can see now he's hooked up and they're getting ready to transport him over into the pool, which you see here, and you can also see the divers to the sides that are assisting with making sure things don't get tangled up. In addition to seeing the interiors of the space habitats and the International Space Station mock-ups, we also were able to see things like the Mars rover and other terrain type of vehicles and really get a sense of the size of all of these things. So here is one of the rovers that has been used, and you can see it'll fit 2 people in the front seat, and then there are a few other seats behind that, again with escape hatches. You can also see some Velcro dangling from the ceiling there, and currently all things are held in place using Velcro, but what they have found is that the Velcro actually starts to break apart and gets in the air filtration system. So the materials that can be used in space are really limited for a variety of safety reasons. Of course, the emphasis is on keeping people alive. So these are just some of the systems for generating oxygen as well as recovering and recirculating water, which are the two big things that need to happen in order to keep people alive. The cupola, which you are seeing a replica of the cupola that is currently on the International Space Station, is the most preferred environment for the astronauts. They like it because it's the only part that has windows. Windows are exceptionally hard from an engineering point of view to make work. And the astronauts like this because they can see back towards planet Earth depending on where they are in the orbit at the time. Here are some more examples of the equipment and a spacesuit. And what you're seeing in the background is the actual second version of the International Space Station and its component parts, this time in a warehouse type of environment where they study how the astronauts are able to perform various tasks while suited up in spacesuits. So this one has Earth gravity, of course, but between this and the submerged version, they can try to get as close to what it will actually be like for the astronauts. Until SpaceX started being used to send astronauts to the International Space Station, for the past several years, the Russians had actually been sending all North American astronauts in their equipment. And so here you see the actual unit that was used, designed by Russia. The students got to see how the space habitat team, and you're seeing a couple of them here in the background, and then the 4 students are working on how they built these full-scale mock-ups. There is a kind of framing system that is used so that things can be suspended from that frame while they are mocking up the actual sizes of things. And this is how they really start to figure out if something is going to work for the astronauts. So they will build something and then have the astronauts test it once it's ready. These are some images from Metropolis magazine of the actual International Space Station with astronauts in it. And you can see there is quite a bit of stuff. The environment is cluttered. It has a lot of wires, exposed wires, and because people are floating through this environment, it's a little bit dangerous as they try to grab hold of things to navigate. So these were some of the issues we were looking to resolve in the student design solutions. All space habitats have an arrangement. These are the common arrangements that NASA has tested. They have a whole criteria matrix related to these different configurations and the pros and cons. And this is what the students used in order to guide their design process, the information based on the pros and cons of these different types of configurations. Of course, space is fascinating, and here you see a view of an astronaut. He's tethered to the space station, but the whole idea of floating out in space, of course. And then here is a view of the actual cupola and how they can look back and view planet Earth, which is one of the reasons why it's so incredibly popular with the astronauts on the International Space Station. So now into the student projects, I'm just going to show you a couple of views. This first one is for a lunar surface solution. We have project that is inspired by the whole surface of the moon, in this case the craters and different textures of the moon. The solution was to create an environment that relies on the use of AR and VR so that it can be a clean environment unless someone wants all the information that can only be revealed through wearing these goggles. So it's a combination of touch control, auditory control, and then visual tracking to see what all the systems within the space habitat, what they are actually tracking. Here is a section view, and it shows you there is a separated sleeping pod on the first level, exercise area on the second level, and then the laboratory is above with a cupola. And this shows you that everything can become a screen that the astronaut can interact with, but when they don't want that information, they can turn it off. The second design is of a 2-module habitat, one for living and one for working. It relies on the use of biophilic design elements as well as a circadian lighting scheme to simulate sunlight on Earth throughout the course of the day, as well as plants to bring in the element of nature. And to really try to provide for some of the human needs within this outer space environment. Here you can see the 2 modules. Both of them have sort of adjustable transformational type of elements on the inside. So here you see the exercise area, which folds down and out when that needs to be used. Here you can see the lounge area, which can change depending on if they are sitting and socializing or if they want to watch a movie. And here is the collapsible sleeping pod, which allows for the private spaces when the astronauts want to have privacy. Now, since there is a lack of gravity, in this particular configuration, you're seeing they are upright, but they won't have the sense of being upright when they're in there because of the gravity conditions. Storage is a huge component of this project, and as we saw in The Martian, those canvas bags, it actually, they need a lot of those because every single thing they need and every single piece of garbage that they create has to go into one of those canvas bags. And so this is showing how between the 2 modules they can accommodate 390 of those stowage units, which is really what's required. The next project is also for a lunar mission. It is a 2 habitat module with an EVA, which is where the astronauts have to go to suit up before going out of the gravity conditions of the module and into outer space. So that's what you're seeing here. Here are some interior views. Again, the use of AR and VR, lots of tracking of body functions, temperature, humidity, oxygen, and so on is required. So you can see all of that is here, but the wires and different things are behind panels so that they can be easily accessed, but they aren't dangerous in terms of you won't grab onto them to stabilize yourself. And here is a floor plan view so you can see how the 2 modules and the EVA work together. This one also uses a circadian lighting scheme to create a natural day cycle so that the astronauts can feel like they have that. There is also a water recycling system and the introductions of some natural elements. And here you can see the kitchen unit as well as the cupola at the top. The next set of projects are for the Mars. One is a surface habitat and one is an orbiting habitat to allow for the construction of the surface habitat. So because Mars has no plants or water that have been found, this unit was designed to introduce both, so that there is a water recirculating system as well as the ability to grow plants, both edible plants and plants to use to filter the water. Here you just see what the timeline for the mission is. And this shows you some of the elements of the student-designed space station habitats. So the water circulating diagram is being shown on the right-hand side, and that really is powered through the astronauts walking up and down the step ladder. So that will actually help to recirculate the water. It can be done mechanically, but this allows for combining exercise with a mechanical process. And then these show you some views of those plants that are on the interior that are used to actually filter some of the contaminants out of the water and allow it to be reused. You can also see the stowage bags along the edges. And here is another view. The last project is for the orbiting unit for Mars. It consists of several modules that allow for the construction of the surface habitat while orbiting around the planet. And so you can see both the plans at the top here and then some section views, so that there are living and working pods, and also the ability to be together and apart, as well as exercise and all the other things that need to happen. Here is an overview of what that looks like split into two, so you can kind of see the lounge pod and the kitchen pod, and then also the overall exterior, what it looks like, and the solar panels that are powering it. So when we go to the inside, like many of the other design solutions, there is some nature introduced to the interior, and there are these panels behind which all the wires are stored, but they're easy access. So you can see all these different handles, like so you can open up and access something. Using a combination of AR and VR, it will also project what is in all of these different areas so that it's easy to find something in the case of an emergency. The blue grab bars are a contrasting color so that they're easy to see and grab onto to circulate through the environment. And here you can see the top view of the inside as well as an exterior perspective of this unit orbiting in space. So there were many, many, many research sources. Of course, NASA is a huge resource for this. They have lots of guidelines. Most of it is focused on keeping people alive, which of course is critical. And so what we were hoping to contribute to this project is how to integrate technology to allow people a connection to planet Earth and home, which is really important, as well as separate things acoustically, allow for privacy and socialization, which are both important, as well as control for sound, smells, and some of the other issues that astronauts have complained about in the current International Space Station. So my final thought is that I began by saying one of the main reasons that these are being developed is to give us a second place to send humans because of what is happening on planet Earth. And what you're seeing here is some of the trash that has been left on the moon. So I would just suggest that if we are looking at another place as an alternative, we treat it differently than we have treated the planet we are currently on. So thank you very much for listening to my talk. If you want to reach out to me, I can be contacted by email at ltucker, for Lisa Tucker, at vt.edu, VT as in Virginia Tech. Thank you very much, and I hope you enjoyed this talk.